Alright, number 29 starts with 2 cosine squared on the top and 1 minus cosine 2x in the denominator. So I'm going to use that the power reducing identities again. And remember that 1 minus cosine 2x is the same thing as 2 sine squared. So I've got 2 cosine squared over, that's going to be replaced with 2 sine squared. The 2's can simplify out, and cosine squared divided by sine squared is cotangent squared. And we're done with that problem. Let's look at number 30. Number 30 says 1 minus tangent squared over secant squared equals cosine of 2x. Okay, so normally I would say I would always work from this side because of the double angle, but I think what I want to do is I want to replace what it equals and then work the left-hand side. So cosine 2x, let's see, cosine 2x could equal cosine squared minus sine squared. I'm just going to write these down, because if I get to any of them, then I'm good. Cosine squared minus sine squared, 1 minus 2 sine squared, and 2 cosine squared minus 1. So if I can get this side to look like any of those three, right, then I know I'm good. Okay, because I'm not going to recognize cosine 2x when I see it. I'll recognize these, though. So I've got 1 minus tangent squared. So 1 minus sine squared over cosine squared over 1 over cosine squared. Common denominator. I'm going to multiply top and bottom by cosine squared up here. So I'm left with cosine squared minus sine squared over their common denominator cosine squared. And then I'm going to flip and multiply by the reciprocal of 1 over cosine squared, which is cosine squared over 1. And then I can see that the cosine squares will go away, and I'm left with cosine squared minus sine squared, which I know is another form of cosine of 2x. And we're done. So that's 30. On to 31. I'll take a picture of that page real quick. Okay. Number 31 says 2 cosine squared tangent squared equals 1 minus cosine of 2x. Okay. Interesting. I've got 1 minus cosine 2x, and I've got this over here. Okay. So let's just go ahead and start working it. 1 minus cosine 2x is, again, hopefully you're getting the idea that these are really useful, is 2 sine squared. If I thought of it another way, I could replace cosine 2x with a quantity and then subtract. So distribute the minus and the ones would go away and you'd be left with 2 sine squared. But it's just much easier to see 1 minus cosine 2x is 2 sine squared. So I'm going to work it both ways. I'm going to work it right to left and left to right. So if I work it right to left, then I would say, well, this is 2 sine squared. And then I would think, well, I need 2 cosine squared. I've got the 2. I need a cosine squared times a tangent squared. A tangent is sine squared over cosine squared. So if you notice that, I need a cosine squared in the numerator and I need a cosine squared in the denominator, which means just multiply top and bottom by cosine squared. And then I could say, well, that right there can be tangent squared, so 2 tan squared cosine squared, and I know I'm good. The order doesn't matter when you're multiplying. But if I worked right to or left to right, then I could say 2 cosine squared times sine squared over cosine squared. Cosine squares could simplify out, and I'm left with 2 sine squared. And then my power reducing identity, sine squared is all of that. Although you could say the 2 sine squared, but I'm going to go ahead and do this. So 1 minus cosine 2x divided by 2, those go away, and I'm left with 1 minus cosine 2x. And then we're done. Then we have 32. Let's see, 32. So 32 says secant squared times sine of 2x equals 2 tan x. So when I look at this one, sine of 2x is definitely something I want to replace because I don't, I prefer just single angles. So I've got, I'm going to go ahead and rewrite this as 1 over cosine squared times 2 sine cosine. So sine 2x is 2 sine cosine. Then I see I've got a cosine in the numerator, cosine, 2 cosines in the denominator, so one of those cancels out with one of those, simplify, so I'm left with 2 sine divided by cosine, and sine divided by cosine is tangent. So 2 tangent. Okay. Number 33. I was on a different page. So I'll end this video here and then